Okay, 11.1b, this is part 2 of simplifying radicals. And there's 2 parts to this video. The first part is about simplifying a square root with variables. So what happens when we have variables under the radical sign? So there are some rules. What does this mean? The square root of x squared. Well, we could break this to the square root of x times the square root of x. And every time we have the square root, the same thing twice under the radical sign, it equals just plain x. So using that same logic, we'll do radical x to the third. Well, that would be 3 of these. We could take the first 2, and that would just be plain x. And now we have x times radical x. And I would have to leave the second one under the radical sign. Radical x to the fourth, we would write it out 4 times. And the first 2, radical x times radical x, is just plain x. Second 2, radical x times radical x, just plain x. And so the answer to that would be x squared. Radical x to the fourth is x squared. Radical x to the fifth. If I wrote it out 5 times, 1, 2, 3, 4, 5. The first 2 is just plain x. The second 2, just plain x. The last one has to stay under the radical, so the answer is x squared times radical x. Okay, now you should probably be able to see the pattern of what's going to happen, but if you have to write it out like I'm doing now, then do it. If you could do it without writing it out, then fine. Did I write too many? No. 1, 2, 3, 4, 5, 6. Every 2 of these goes to just plain x. And I end up with 3 of them, which is x to the third. So, example 1, we're going to simplify 40 x to the fourth, y to the fifth, z to the third. So I'm going to do the 40 separately. Radical 40, I'm going to break down to radical 4 times radical 10. Radical 4 is just plain 2, and radical 10 can't be broken down anymore. So it's 2 radical 10. So I'm going to write the 2 on the outside. I'm going to leave some space. I'm going to put the 10 on the inside. Here I'm getting the 2 on the outside, 10 on the inside. I'm going to add more for the variables now. So rad x to the fourth, we know we're writing it out 4 times, and every 2 gives me an x. So that would be x squared, and that's on the outside, not under the radical sign. Rad y to the fifth, you're writing it 5 times, or you can do it without writing it out if you're able to. 1, 2, 3, 4, 5. First 2 come out as just y. Next 2, just y. The last one's under the radical sign. So I have y squared on the outside. And I have a y on the inside. And now I'm going to do the same thing for z to the third, writing it 3 times. Oops. First 2, that's a z. First 2 come out just z on the outside and 1 z on the inside. Z on the outside, 1 z on the inside. And this is how I'd write my answer. Okay, let's do another one. Number 2, simplify radical 60 x to the fifth, y to the sixth. So I'm going to do rad 60 first. I'm just going to break it to rad 6 times rad 10. Rad 6 breaks to rad 2 times rad 3. Rad 10 breaks to rad 2 times rad 5. To simplify what I have there, the rad 2 times the rad 2 will equal just plain 2. Rad 3 times rad 5 have to be combined back together to get rad 15. So far I have the 2 on the outside, 15 on the inside. Now I'm going to break down the next one, rad x to the 5th. Well, you might remember, or you might start to get it, there are 5 of them. The first 2 come out and be x, the next 2 come out to be x, the last one stays in to be x. So I have x squared on the outside, just plain x on the inside. Y to the 6th, there are 6 of them. Every 2 break down to just be 1. So I end up with y to the 3rd on the inside. And that's the answer to this one. Okay, the second part of what we're doing, I need to review a rule with variables under the radical sign in a fraction. So that could be broken down to rad A over rad B. So if I had numbers, rad 49 over rad 4 could give me radical 49 over radical 4. These both happen to be perfect squares, which you would just break it down to 7 over 2, and that'd be nice and easy. But sometimes the radical on the bottom is not a perfect square, and if it's not, we have to do, this is the second part of this lesson, something that's called rationalize the denominator. So, what does that mean? Well, I'm going to do rad 10 over rad 3. I have a radical in the denominator, and this, if it's not a perfect square, it's an irrational number. We can never leave that irrational number in the denominator. So we're going to do something to it called rationalizing the denominator. And all we do is we take whatever that radical is, radical 3, and I multiply both the top and the bottom by radical 3. Why is that okay to do? Because radical 3 over radical 3 equals 1. Anytime you have the same thing on the top and the bottom of a fraction, it just equals 1. So it's okay to multiply it by 1, it doesn't change anything. But it does rationalize it. So I'm going to multiply what's on top, that gives me rad 30. I'm going to multiply rad 3 times rad 3, that gives me just plain 3. If the top is a radical that I can break down, then I will do it. Rad 30 can't be broken down, it just equals rad 6 times rad 5. Rad 6 is 2 times 3, so 2 times 3 times rad 5. None of these are perfect squares, so you leave it just like this. Okay, next example. Let's do rad 2 over rad 6. So I have I don't have a perfect square, I have an irrational number in the denominator. So I'm going to rationalize the denominator by multiplying the top and the bottom by whatever the bottom is. So that gives me rad 12 on top, and rad 6 times rad 6 is rad 36, which equals just plain 6. Now I'm not done with this one yet because rad 12 can be broken down. So when I simplify rad 12, I'm simplifying it to rad 2 times rad 3. I'm simplifying rad 12 to radical 4 times radical 3. Radical 4 is just plain 2. So I now have on the top 2 radical 3 over 6. Not done with this one yet because I have a fraction that can be simplified. Just plain 2 over just plain 6. neither one is under the radical. So I'm going to divide them both by 2 and get 1 rad 3 over 3. That one right here is not really needed, so your answer would just be rad 3 over 3. That one involved a little bit more work. Let's do, let's try this one. Rad 3 over 10. I first need to change it to radical 3 over radical 10. Now I need to rationalize the denominator. I multiply the top and the bottom by rad 10. I get rad 30 over rad 10 times rad 10 is just plain 10. Rad 30 cannot be broken down, so I leave it like this. Let's do just plain 4 over rad 6. I need to rationalize the denominator, multiply by rad 6 over rad 6. I get 4 rad 6 over just plain 6, because rad 6 times rad 6 equals just plain 6. I need to simplify this fraction, multiplying them both by 2. I get 2 rad 6 over 3. And that's how I leave that answer. Let's just do one more. Let's do rad 5 over rad 8. So to rationalize, we multiply by rad 8 over rad 8. We get rad 40 over just plain 8. We can break down rad 40 to radical 4 times radical 10, which gives just plain 2 times radical 10. I now write 2 rad 10 over 8, and then I simplify 2 over 8 and get rad 10 over just plain 4. And that's that answer. Okay, you now are going to do page 844, top of the page still, number 5, 9, 17, and 18. Make sure you have those 4 problems done in addition to this video.